Hi everyone, this is the video for Graph section 5. In this video I'll give a little introduction and then I'll give an overview of the worksheet. I used to work out the answers to the questions that are on the worksheet in these videos, however I'm not going to do that anymore. I'll just give detailed answer sheets and they're over on my Instagram page, so check that out if you want to see the worksheets as well as the answer sheets. Right, so this worksheet we go over quadratic functions, how to plot quadratic functions, and then how to sketch quadratic functions. In the algebra topics we went over quadratic equations. Now, the difference between quadratic equations and quadratic functions is that quadratic equations just contain one unknown, say x, whereas quadratic functions contain two unknowns, usually x and y. No bigger, it just means that we can now plot them on a graph. We can plot that function on an xy plane. What is the difference between plotting graphs and sketching graphs? Well, plotting a graph is putting values of one variable into the function and calculating the second variable and plotting those coordinates, those pairs, on a graph. Sketching a function is just finding key characteristics about the graph. Some of the characteristics of quadratic functions that you will need to find in order to sketch them are the x and y intercepts and the turning point of a quadratic function. This will all make sense when I actually get into the worksheet, so let's just go ahead and do that.
Right, here we are with the worksheet. Shock horror, it's orange. Okay, so what does a quadratic function look like? It looks like this. Y is equal to ax squared plus bx plus c, where a, b and c are usually numbers. Remember, in the algebra topics, a quadratic equation looked like this, but instead of the y here, we had a 0. That's because quadratic equations are just a special case of a quadratic function. A quadratic equation is a quadratic function, but where y is equal to 0. So, what do quadratic functions look like when they're plotted? Well, I cringily remember that quadratic functions when plotted look like symmetrical smiley and unsmiley faces. So here, this is a quadratic function when plotted. This is the smiley quadratic function, and down here, the unsmiley quadratic function. It's a bit embarrassing, I know, but I've never forgotten it, so that's just how I remember it. You can also remember them as symmetrical U shapes and upside down symmetrical U shapes. So that's what quadratic functions look like when plotted, but don't take my word for it. How about we have a look at plotting our own quadratic function, and then you can see they're going to turn up and look something a bit like one of these two. So in this example, we're given the question, plot the quadratic function for all values of x between -5 and 3. And this is the quadratic function here. Y is equal to x squared plus 2x minus 8. So the first thing I do when I'm plotting a function or an equation or anything really is I draw a table. I make the top row the x values. These are the values that I know or I've been given. In this example, we've been given what x is. X is between -5 and 3. And then the bottom row of the table is the y value, i.e. it's the thing we're going to find. And what I do is for each value of x that I've decided or I'm given, I plug that value of x into the original quadratic function. I then solve it and find the value of y, and I put it here. So it's below the corresponding x value that I just put into the function. This then gives me a collection of x and y pairs that satisfy this quadratic function. These x and y pairs are also coordinates, i.e. if this quadratic function was plotted on a graph, then these x and y pairs are the coordinates which this quadratic function will pass through. So if I plot all of these x and y coordinates onto this graph, I can then join up those points, like a bit like dot to dot, and it will map out what this quadratic function looks like on a graph. That's the plan. That's what I usually do when I have to plot something. So let's just go ahead and do this. Let's plot this function here. I've written out the table. I've also written out the x values, and now I have to find the corresponding y values. So if x is -5, what I need to do is I need to replace every single value of x in this quadratic function with -5. Work out what this answer is, and it tells me what the y value will be. So if I had x as -5, this term here becomes minus 5 squared. Well, that becomes 25. This term here becomes 2 times by minus 5. Well, that becomes minus 10. And then we still have the minus 8. So this quadratic function would read y is equal to 25 minus 10 minus 8, which is equal to 7. So that tells me that when x is minus 5, y is equal to 7. And I would write a 7 there. This means that the pair x is equal to minus 5 and y is equal to 7 is a solution to this function, and therefore the coordinate minus 5 and 7 is a point on the graph which the quadratic function passes through when it's plotted on a graph. So here I've now written the 7 there in that table, and I have plotted that coordinate on the graph here. Now what we do is just rinse and repeat for all these other values of x. Here we go, we've filled out the table, we've found all the y values. We've also marked all of the coordinates on the graph with these little x's here. Now the last thing to do is join up these x's so we have a visual representation of this quadratic function. Now remember, you don't want to join these x's up with straight lines because we know that quadratic functions look like U-shapes or smiley faces, i.e. they're curved. There's no real straight lines involved with these. So what it's going to look like, it's going to look like a little U-shape that comes through all these points. And here it is given by this orange line. So this orange line here is a visual representation of this quadratic function here. And we've just gone through how to plot it. There's a second example here, and I've actually already plotted it on the graph. Notice that this one is an upside down smiley face or U-shape. That's because there's a minus in front of the x squared. In general, if you have a minus in front of the x squared, you're going to get the upside down or the unsmiley face. So that's how we plot quadratic functions. Now, how about if we want to sketch quadratic functions? So sometimes you don't need to be so accurate when you're wanting to draw a quadratic function. Like when we plot quadratic functions, we're really accurate. If you don't need to do this, if you need to just sketch the quadratic, then what you can do is you can find a few key characteristics about the quadratic function, plot these on a graph, and then just join them up using your knowledge of what a quadratic function looks like. So what are these key characteristics that we can find? Well, they are the x-axis intercepts, the y-axis intercept, and the turning point. And I'll explain what all of those are using these little charts again. The x-axis intercepts are the points at which the quadratic function crosses the x-axis, these points here, i.e. it's the point at which y is equal to 0. Remember, the x-axis line here goes through the point at which y is equal to 0. Similarly, the y-axis intercept is the point at which the quadratic function crosses the y-axis. It is the point at which x is equal to 0. Remember, the y-axis here crosses the point at which x is equal to 0. So they are the x-axis intercepts, and this is the y-axis intercept. And on this example here, these are the x-axis intercepts, they're where they cross the x-axis, and the y-axis intercept is here. It's where the quadratic function crosses the y-axis. Now, the turning point of a quadratic function can be thought of in a number of different ways. Firstly, it can be called a turning point or a stationary point. And how you can remember it is the point at which the quadratic function changes direction. So here, the quadratic function is going up, 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 and then all of a sudden, oh, is going down. And it's the point at which it changes direction that is where the turning point occurs. Same with this one. Oh, we're going down, 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 down. Oh, and we're going back up. So here is the point at which I changed my stupid voice and I decided to go up instead of down, and that is the turning point. If you want a bit more information on this, you can also think of the turning point as the point at which the gradient of the quadratic function is 0. So if you remember what I said about gradients in previous graphs topics, gradients are the steepness or the slope of a curve or straight line. So turning points occur when the gradient is 0. That's why some people call these points stationary points, i.e. it's the point at which the gradient is 0. So there we go, x-axis intercept, y-axis intercept, and turning points. So once you know these characteristics, you can plot their coordinates on a graph and just join them up. The result is a sketch of a quadratic function. So let's look at an example of this. Right, we're given the function y is equal to minus x squared minus x plus 2, and we're told to sketch it. First thing I know is, well, I know it's a quadratic, so I know it's going to be U-shaped or smiley face. I also know that there's a minus in front of the x squared, so I know that it's going to be an unhappy smiley face or an upside down U shape. Next thing, I've been told to label the intercepts and the turning point. So it's already telling me I've got to find some key characteristics. So let's work out the points at which the quadratic function crosses the x-axis first, i.e. we're going to work out where the x-axis intercepts are. Now remember what I said, the x-axis intercepts occur where the quadratic graph crosses the x-axis, i.e. the point at which y is equal to 0. Therefore, to find these points, we just put y is equal to 0 in our quadratic function and solve. So that's what we've done here. We've now got minus x squared minus x plus 2 is equal to 0. You're going to need to use some of your algebra knowledge here to solve this. I've linked the videos for solving quadratic equations down below in the description box. So this becomes these two brackets here, and from these two brackets we can work out what the x coordinates are of the x-axis intercepts. So we get x is equal to 1 and x is equal to minus 2. Therefore, the x-axis intercepts are 1 and 0 and minus 2 and 0. These zeros here come from the fact that we said y is equal to 0, and the 1 and minus 2 correspond to the x values that we've just found. So these are the x-axis intercepts. Done. Brilliant. Let's move on. Next thing to work out is the y-axis intercept, i.e. the point at which the quadratic crosses the y-axis. Again, remember, this is the point at which x is equal to 0. So all we do is we go back to our original quadratic function and we replace all the x's with 0, and we solve to get what y is. So here, this is the original quadratic function, and we replace the x terms with 0, so we get y is equal to minus 0 squared minus 0 plus 2. Therefore, y is equal to 2. Therefore, the y-axis intercept is the coordinate 0 and 2. We already said that x is 0, so that's where the 0 comes from, and we've just found out that when x is 0, y is equal to 2, so there's the y. So this is the coordinate for the y-axis intercept. Brilliant, we found all the intercepts. Now the last thing to do is to find the turning point. So to find out the turning point, we need to use a bit of knowledge of what we know a quadratic function looks like when it's plotted on a graph. Well, what did I say? Quadratic functions look like symmetrical smiley or unsmiley faces. They also look like symmetrical U-shapes. The fact that they're symmetrical is really important because what it tells us is if we look at these examples here, because they're symmetrical, this turning point here or here has an x coordinate that is always halfway between the x-axis intercepts. So to find the x coordinate of the turning point, all you have to do is take the x coordinates of these 2 points, the x-axis intercept, and find the halfway point between them. So let's just go back to the example and I'll show you what I mean by all this. X is equal to minus 2 plus 1 over 2, i.e. what we've done is we've gone up here and looked at what our x-axis coordinates are, 1 and 0, minus 2 and 0. We've taken the x values from those and we've found what the midpoint is between these two. It doesn't matter which way around you do it. You could do 1 plus minus 2 all divided by 2, or you could do minus 2 plus 1 all divided by 2. It doesn't matter. You always get the same result. So the midpoint is minus a half, i.e. the x coordinate of the turning point is minus 0.5. Now we know that, we can plug this x value back into our original quadratic function to find the corresponding y value. From that, we then have the full coordinate of the turning point. So here we go. If x is minus 0.5, then our original quadratic function reduces down to y is equal to 2.25. Therefore, the coordinate of the turning point is this guy here. Okay, so we found all the key characteristics. We have found the x-axis intercepts, we've found the y-axis intercept, and we've found the coordinate of the turning point. All we have to do is plot these points on this graph here, and then using our knowledge of what a quadratic function looks like when plotted, we'll join up those points and we're done sketching that quadratic function. So here I've plotted the points. These are the x-axis intercepts. We had -2 and 0 and 1 and 0. These guys up here. I've then marked on the y-axis intercept, which we had as 0, 2, which is this coordinate here. And finally, this mark tells you the turning point of the quadratic, and it is the point -0.5 and 2.25. The final step is to draw through these points. So there you have it. This white line going through the yellow points is the quadratic function. Cool. I think now is probably a good point to test your knowledge, so you can try out these questions at the bottom here. I used to video myself answering these questions, however now I just provide a detailed answer sheet which I put up on my Instagram page. The link for that is down below in this description box, so head there if you want to see an image of this worksheet as well as the detailed answer sheet which has workings as well as the final answers. Cheers for watching.